So let's learn what the normal force is. Normal is expected. No. Normal is usual. No. Normal here is perpendicular. What do I mean by perpendicular? Look, the object here is in contact with the ground. It has a weight W downward, and the surface in contact with the object will cancel the weight by generating a normal force. This is perpendicular to the surface. Here, normal force seems to be equal to weight. If the weight is W, it's also W. But they are not always like that. The case like this, when the object is pushed down by an external force of F, will not have a normal force equal to W. Or whenever the object is pulled up by an external force like F, or the object may be acted by a force, oblique force, which is not totally vertical or totally horizontal. What should I do in this case? There are some other cases like this when the object is on a ramp. The cases like this when you push an object horizontally and hold it on a wall. Or the cases like that when the object is in an elevator. The elevator may be accelerated upward, accelerated downward. What should I do with this case? These are all the things we will learn in this video. If you are ready, let's go. Here I have a mass of 2 kilograms, and let's say G is 10. So the weight is mg, 2 times 10, so it's 20 newtons downward, okay? I'm looking for the normal force. I believe that the net force acting on the object is 0 because the object is not accelerated. At least I know that it's not accelerated vertically upward or downward. So the surface in contact will generate equal and opposite force like 20 newtons upward to cancel the weight. Here is a very easy case. But let's say the object, rather than the weight, is acted by a vertical upward force of 14 newtons. What should I do here? You see that 20 newton downward, 14 newton upward will have a downward force of 6 newton, okay? This 6 newton must be cancelled by the surface with a normal force of 6 newton. How do I know that this is 6, not more, not less? Because again, I believe that the object has no vertical acceleration. So this must be 6, not more, not less, to cancel that extra force. Here 14 plus 6 will be 20, and downward is 20, so they cancel each other. The other would be the case in which the object is acted by a downward force of 14 newtons. Here I have a downward net force of 20 plus 14, so it's 34. That 34 must be cancelled by a normal force. How do I know that? Because the object is at rest. It does not have any acceleration. So here the normal force is needed to be exactly 34 newton. A 2 kilogram mass is pulled by a 20 newton force as shown in the figure. As you see, the force is oblique. It's making an angle of 53 degrees to the horizontal. Sine of 53 is given to be 0.8. Cosine of 53 accordingly is 0.6. Calculate the normal force. G is given to be 10. According to that, we should always consider the vertical forces acting on the object because normal force in this case, as the surface is horizontal, will be vertical. So I am looking for all the forces vertically acting on this object. One of them is the downward force of weight. It's mg, mass is 2, g is 10, so it's 20. What about the other forces? I should decompose that 20. Here I know that 20 newton will have a horizontal component of 20 times cosine of 53, and the other component is a vertical component like 20 times sine of 53. Cosine of 53 here is given to be 0.6, so it's 12. And here sine of 53 is given to be 0.8, so it seems to be 16. So if I decompose that force, I will have a 16 newton upward, a 12 newton horizontal. It is not that important for us because I am looking for vertical forces. Normal force is vertical here. Look at just these two forces. 20 down, 16 up. Here, the total net force due to these two forces will be downward force of 4. So the net force vertically must be 0. The object has no vertical acceleration. So I believe that the normal force here must be 4 to be added up by 16 to make a 20 and vertically hold the object without acceleration. What about the horizontal? The horizontal direction is not something we consider now. Actually, if we have maybe a friction here, that 12 Newton will fight with friction. If there is no friction here, that 12 Newton will make a horizontal acceleration for that object. So here, in horizontal direction, Fx must be ma. It's exactly the Newton's second law of motion. So Fx is 12, mass is 2, acceleration a. So horizontal acceleration will be 6 meters per second square. This is not our topic of discussion now, but just I mentioned that this 12 Newton has nothing to do with the vertical. So I always calculate the normal force considering the vertical forces acting on the object. Here, again, be very careful. The object in vertical direction has no acceleration. Now let's find the normal force acted on the object when it is on a ramp. The ramp has an angle of alpha to the horizontal. Here, the very proper coordinate system we always take on a ramp is this. One of the axes is horizontal, or let's say parallel to the ramp, and the other normal, actually normal to the ramp. Okay? Now I'm gonna decompose the mg. mg is always downward. Now I'm looking for angles. Here I should know this angle or this angle to have a decomposition. How to find it? It's very easy. Look at this. Here I have a right triangle. This right triangle, okay? And this is the right angle. So if I take this angle to be x, I believe that x plus alpha will be 90, okay? Because the total internal angles of a triangle will always add up to 180 degrees. So x plus alpha will be 90. On the other hand, this is really a right angle. So if I take it to be y, I believe that x plus y also will be 90. Here I see that y must be equal to alpha. So it's very good. I know that this is alpha. Now I can easily decompose the mg. Here I have the adjacent components to be mg cosine of alpha. And here, this is exactly the component which is opposite. So it's mg sine of alpha. And so in this case, I can say this is mg cosine and the other mg sine of alpha. Mg sine of alpha will accelerate the object downward. It's not our topic of discussion. Here I'm looking for the forces acting on this direction, actually normal to the ramp. What should I do here? I will have a normal force equal to mg cosine of alpha. Why? It's very easy. Because in this direction, the object has no acceleration. Although it may accelerate downward like here, but it won't have any acceleration normal to the ramp. So n must be equal to mg cosine of alpha. For example, let's say here I have a ramp and this is 30 degrees and the mass of the object is 2 kilograms. So let's say the weight is 20. Here I take the g to be 10. So here I have 30 degrees. This is 20 times cosine of 30 degrees. So the normal force will be 20 times cosine of 30 degrees. Done. It's very easy. A force of 12 Newton is exerted normally on the wall. Here as you see. Find the normal force of the wall in response to the force exerted. I believe that in horizontal direction, I have no acceleration. So the object horizontally is acted by 0 net force. So the wall must generate a 20 Newton of force. This is the normal force to cancel my 20 Newton. Vertically, the object may slide down, may accelerate, but it's not important for me because normal force here is normal to the wall. So it seems to be a horizontal force. Look at this one. Here I have an elevator. The object is an elevator, and the elevator is basically accelerated. The acceleration is 2 meters per second square upward. This object is part of that elevator. So the object must be also accelerated with the same acceleration. It's very important. If the elevator is accelerated, all the objects which are part of that and are carried by that elevator will have the same acceleration. What are the forces acting on that 2 kilogram of mass? If I take the G to be 10, I have a downward force of weight, 20 Newton, and a normal force. I'm looking for this normal force. I believe that this object has the same acceleration of 2. So F net acted on the object is not 0. I believe that F net must be, let's write it like this, F net must be ma according to the Newton's second law of motion. Okay, what the F net is. As the acceleration is 2 upward, I believe that the larger force is N and the smaller is 20. This is the winner, this is the loser. So I always write F net like larger minus smaller, or winner minus loser, to be ma. Winner here is N and the loser is mg, is equal to ma. How the winner force is specified, I always check the direction of acceleration. If the acceleration is upward, winner is the one which is upward. Okay, let's substitute the values. I plug in the 20 for that, and mass is 2 and acceleration is 2. So n minus 20 is 2 times 2. N seems to be 24 Newton. So sometimes the normal force, rather than holding the object, is also accelerating that. The other case, which is very interesting, is the one when the elevator is accelerated downward. Accordingly, all the objects which are carried by that cabin are also accelerated downward. So the normal force of N is acted on that 2 kilogram of mass, but it's not enough to hold the object at rest. Actually, the winner here is 20. Why? Because the acceleration is downward, so it's winner and it's the loser. Again, I write F net is equal to ma. Winner minus loser must be equal to ma. So winner minus loser, ma. Mg is 20. I plug in the 20 for that. N is something I'm looking for. Mass is 2, acceleration 2. So here N seems to be 20 minus 4. So it's 16. Here I believe that the normal force is 16 Newton. Thank you for being with me. I hope you enjoyed this lesson. See you in the next video.